Given that y equals ln of ln x, we need to show that dy dx is 1 over x ln x. So if y here is ln of ln x is the inner function, then to find dy dx, the outer function is ln x. That will give us 1 over ln x. And then we differentiate the inner function. That will give us 1 over ln x. When we differentiate ln x, we get 1 over x. So this is 1 over x ln x. The variables x and t satisfy the differential equation. X is e when t is 2. We need to solve the differential equation, obtaining an expression for x in terms of t. X is the dependent variable, t is the independent variable. Then you need to simplify your answer. So let's see over here, we are going to move this over to the right side. We have t dx dt. That is negative x ln x. Since x is the dependent variable, we are going to move x ln x over to the left by dividing, and t to the right by dividing as well. So we have 1 over x ln x dx dt, and this is negative 1 over t. Now, integrating with respect to t, we have 1 over x ln x dx on the left, and we have negative of the integral of 1 over t with respect to t. Now, if we are given that dy dx is 1 over x ln x, meaning that when we integrate 1 over x ln x, that will give us ln of ln x from part A. So from part A, the left side is ln of ln x. And we keep the constant of integration and leave it on the right side. No point writing it twice. On the right side, this is negative ln of the absolute value of t plus the constant of integration. We need to write x in terms of t, so we need to find the value of c. We are given that x is e when t is 2. We substitute these values into the equation here. So we have ln of ln e, that is equals to negative ln 2 plus c. Okay, let's look at this. Ln of ln e is 1. Then we have ln 1, which is 0. Then we have 0 equals negative ln 2 plus c, or c is ln 2. So replacing c with ln 2, we have ln of ln x equals negative ln t plus ln 2. That is actually ln 2 minus ln t. So that is ln 2 minus ln t here. And using the quotient law of logarithm, that will give us ln of ln x. This is ln of 2 over t. Taking anti-log on both sides, we have ln x equals 2 over t. And taking anti-log again on both sides, x is e to the 2 over t. So that would be the solution for part B. Part C, state what happens to the value of x as t tends to infinity. So as t approaches infinity, we look at the exponents here. 2 over t approaches 0, then x, which is e to the 2 over t, is approaches e to the 0, which is 1.